Assalamu alaikum Qtabiyani Khoshist. In today's lesson, we're going to begin a new chapter, which is about electric force and fields. Basha. So, لبابتي ورمان inshallah this babata chino that can babata shtatwani blend. It is totally different from what we've studied so far. It's basi charge electricity bablan. We'll talk about electric charge and electric field as well. Basha. So, what are the things that we will be covering? No chapter what are they? The first one, we'll talk about electric charge, and then properties of electric charge. We'll talk about electric force, and we will also talk about electric fields as well. The first thing to begin with, Basha, which is about electric charge. Before that, we can say there are, like charges have some electrical properties, or we can say electrical properties of charge. Basha. Charges in general, they have three properties, and these are very, very important, and I need you to know them. Basha. Manikan property, you need to know that there are only two kinds of charge, and these are positive and negative charges. The second thing we can say, electrical charge is conserved. What do I mean by conserved? Yani, simply electrical charges can never be, or can either be created or destroyed. Basha. And the third property is electrical charge is quantized. Basha, it's babi kino kurdi. Bitman say sifat man hey bablan for electrical charges. Basha. Kata electrical charge on charge kani bablan electricity karabai se property an hey keman bitman there are only two kind of charge. Tanha do jor charge man hey awanish positive negative. Do I khali dom the twanin blend electrical charge is conserved. Yani o charge yani kahit man nadakre duruz bikre nadakre lana bubren, but they can be transferred, of course, from one material to another, or even within a material from one location to another. Khali same and the twanin blend electrical charge is quantized. Yani had electrical charge had electric charge has a specific magnitude. Barachi taibati here, Basha. So these are the three properties that we will be kind of like discussing each one of them individually. Basha. So rubbing materials like a comb or a balloon against a hair creates an electric charge. These electrical charge, of course, causing attraction to objects like hair or paper. When you comb your hair, of course, if you do that too many times, or especially when your hair is dry, you'll see that your hair will be attracted to the comb. And the reason why, because you rubbing the comb with your hair, that separates the charges. The comb, will be charged with one type of charge. Your hair is another. So these two now can attract one another. So this will be the reason why. If not, if you rub a balloon with it, with your, for example, with your head or the hair, you can see that soon after they will attract one another. Once you're touching a doorknob, you get this annoying spark. That is also a sign of electrical charge being separated. And of course, we know that we'll talk about the type of charges too, but once you rub two balloons, for example, now these two balloons can repel one another, and sometimes, or you can stick a balloon to the wall, Basha. Now, of course, we know that the balloon could be charged, but the wall is neutral. So how can they attract one another? That would be one of the things. So let's talk about each property at a time. Electrical charge man here. What are these two types? Charge positive man here, basha legal charge negative man here. These positive charges come from proton actually, so protons are positive. Negative charge of course, they come from electron, or electrons are negatively charged. But where exactly do they come from? These are coming from the atom. When atomy, we have protons, electrons. Protons are inside the nucleus. Electrons, they revolve around the nucleus. When you kata proton positive and electron negative, we also have another thing which is inside the nucleus, and these are neutrons. But neutrons are neutral, so they don't attract or repel towards charges. Basha kata gutman electric charge exists in two forms. Positive V and negative V. So we can write positive Q. Q stands for charge, by the way. Basha. Sometimes we can also write positive E here. E stands for a charge as well, Basha. But other than E for electron, but when you see a positive, this is a positive charge and this is a negative charge, or you can say negative E, that would be standing for negative charge. And we also know that if you have positive charges, or negative charges, they repel one another. But if it is positive negative, they'll attract one another. Kata positive, negative, repel. We can say like charges repel, but if it is unlike charges, like one positive, one negative, then they can attract one another. زۆر باشە شتێکی دیکەشمانەیە we have something called neutral charge بابە neutral مەبەستمانچەیە and if we start with this one گوتمان like charge repel opposite charge attract just like for example this one we have something called neutral charge what is neutral charge کاکە توانین بڵێن if we have an object of course or objects in nature they are neutral. What does it mean neutral? That means they have the same number of protons and electrons in them, which makes the overall charge of the object to be 0. For example, now we have 4 positive charges here, and then 4 negative charges here. So the total, we can say, or the net charge on the object, that one in Belen net charge, Q net beta 0. But if an object is neutral, can we say it has no charge at all? اگر objective neutral بود دتوانیم بڵێن هیچ چارجی لەسەر نییە نەخێر چکە چارجی تێدایە بەڵام چارجەکان because they have the same number of protons and electrons کاتە با بڵێن یەکدی cancel دەکەن یانی effect یەکدی cancel دەکەن کاتە is the same as if we say there's no charge in it but in reality it is there are charges in them. شتێکی دیکەشمانەیە charge interaction here بابا گوتمان once you rub باشە let's say one object especially a piece of plastic with a piece of wood, let's say, once you do this, now this process here or this mechanical energy here will force the charges from one object to move and to transfer onto the other object. So by doing this, you can make the two objects to be charged, Basha. But normally these are called electrostatic because charge a kind of object decay, they will not go to anywhere else. So that is electrostatic. This is how you can build charges on objects here. Basha. The second thing that we have, Gutman, second property is electric charge is conserved. Gutman, we have the love conservation of energy. We have the same thing for the love conservation, but for the, we can say for the law of electrical and the conservation of electrical charge. What is it called? Basically the number of charges and Babylon charges can neither be created nor destroyed. But charges of course can be transferred from one object to another. The total charge in an isolated system always remains the same. What do I mean by an isolated system? If it doesn't go to the surrounding or any other places, if you have two objects, let's say in an isolated system, اگر object and do electron bablan loose katten of course obviously will gain that two electron if one of them gains the other one loses and you have studied in chemistry if an atom gains an electron it becomes negative and we call that a negative ion but if it loses an electron it becomes a positive ion. So this is exactly what we have why it becomes a positive or negative ion baba that is because of this. Let me give it, for example, let's say we have an object that has, let's say, or it is neutral first. So which means that it can have, let's just assume that it has 3 positive charges and 3 negative charges, Basha. So if by rubbing, let's say, it lost one of the charges, Basha, but before losing, Gutman, say positive man, legal, say negative. So total, look at the beta, 0 net charge. 0 net charge. But if one of them is losing, let's say one of the electrons, let's say to another object in here, so you can erase this one now, Basha. So at this point here, this is what will it become. So at that point, now you can see that after it lost a charge, so good majmare positive I can say, but now it's the do electron the net or the result that is going to be positive 1, Basha. This is why we say if an atom, Basha, or a molecule, let's say, doesn't matter. If it loses an electron, it becomes positive. Basha, what if it gains an electron? Why will it become negative? Let's say we have another charge, Basha, an atom that has 3 positive and 3 negative. If this one gains an electron, it's 4 electron and 3 proton. If an object gains an electron, it becomes negative. But if it loses, it becomes positive. Again, if it loses, becomes positive. اگر gain بيتن جماري الكترون كان زيادة دبي negative. ما no charge ions of course they come from an atom باشا. Charge transfer good man of course atoms are neutral when protons and electrons are balanced باشا. good man transferring electron creates ions باشا. when good man if it gain يعني bubble and if it loses أوقاتي the beta positive ion. If it loses electron becomes positive ion. If it gains electron it becomes negative ion. So كجماري electron and proton كان زيادة دبي. What happens what happens during the interaction between a balloon and hair when they are rubbed together? Good man, rubbing a balloon on hair increases the contact and enhances charge transfer. كاتا the twine balloon charge كان لسر هيري they will move onto the balloon. when استا balloon كده بيتا negative استا now less negative left استا babbling less negative is left on the hair. كاتا the hair is positive and we know that positive negative attract. كاتا the balloon can attract the hair now, and this is the result of that. Masha? Now, the third point here, we have electric charge is quantized. Electric charge is quantized. Har charge it has a specific magnitude. That is what I mean by that. And that also, we can say it is a multiples of a fixed quantity. Basha. So, of course, who is the first scientist who noticed this? Kaka Gutman. In 1909, Millikan observed oil droplets between two charged plates. Basha. We can say the droplets charged by friction were attracted or repelled based on the charge split. So what exactly did he do? He brought some oils, and of course you can say with this atomizer, he sprayed these charged particles. These charged particles, of course, due to gravity, they were falling down. Because of friction, these particles were charged, Basha, and because of gravity, they were falling down here. So after they were falling down, for example, then he was kind of like controlling the charge on these plates. Let me give you an example. For example, positive beaten, he can make this plate negative. Now, of course, this and he was observing this. Now, this positive charge will be attracted to this negative plate because the bottom plate would be positive. We know that positive repel, but positive negative would attract. Negative man habuba, for example. In this case, he would have done this. For example, he would have made this side, let's say, positive, or the other side, let's just say this side positive, like negative. Now, if it is a negative charge, we know that negative repel, or this negative will be attracted to the positive. So he would have used, or he did use this method to study the behavior of these particles, like inside or in between these two plates. And so based on this, of course, he observed millions of, for example, droplets by doing this process over and over. So he got into a conclusion that charges are quantized. What exactly did he say regarding that? He found that the charges on any object, it is always a multiple of a fundamental charge, and we can call that E. So we can say the smallest amount of charge that we can have, it is the charge of, or the charge on one electron, Basha, and we can call that a fundamental unit, Basha. But man, charge on a kaden, Baba. These are coming multiples of fundamental unit. When we talk about charges, we'll say, for example, one charge, two charge. Do we ever say half an electron, for example? No. So it is always in whole number. Kata hamujmare charge kan kaden yan bablin jmare electron kan kahitman au charge ane kahitman britiella jmare tawi bablin كمترين بريان babbling fundamental unit can basha and basic unit can. Of course, this confirmed that the charge is quantized, يعني براتشي تايبتي here, which occurs babbling, it takes place and babbling تنادك تن ببيتا babbling electron yan تنزاري electron نتشي باشا أو زدكري أو charge أنا positive yan negative بن باشا. قلت man charge of a particle دي charge particle كتير قلت man the electron has a negative charge, protonish, positive charge here. The value of electron, the value electron that the value of a fundamental charge, an electron is approximately, not the electron, any value fundamentally, also whether if it is proton or electron, charge what is the value for that? It is 1.6 the O2 times 10 to the power negative 19 coulomb. You can say this is the fundamental charge, Basha. This is the smallest amount of charge that you can have, Basha, which is the charge on an electron. on a charge. So it could be this charge on a proton or electron. What is the magnitude of a fundamental charge? You'll have to say it is 1.6. You can say O2 or not, doesn't matter, Basha, as long as you say 1.6 times 10 to the power negative 19 coulomb. Basha. طبعا fundamental charge تنها به whole number ديتن وذكري مثلا أو جماري تنزارب كيوا والله ناكري بفراكشن بيتن يان جماري ديك بيتن باشا ناكري بس ذكري أو يان تنزارب كينو قلت مان كدلين charge بابا ليرة أقال لي بي ما بس مان أو إيه إلكترونية ما بس مان charge it could be the charge of a positive يان proton or the charge of an electron باشا it doesn't matter باشا ذكري بروتوني بيان an electron بي هو ما بس مان ليرة value يعني without a negative so this is the magnitude of that. طبعا أجر proton we will say positive أجر electron we will say negative this much. وشتاش دي كشكازو كين قبزاني بابا the SI unit of a charge is coulomb. Atten simply charge it is Q. That's what we're using. باشا unit تكيتيا يعني SI unit it is coulomb باشا. It is coulomb. And of course we'll use the letter C for coulomb باشا. سيدي كشمانية. قلت مان to find the total يعني to find the total number of charges أو equation إيش معناها هركاتك قصة مثلا for example if you have a charge of 1 coulomb 10 electron piece that in order to make up one charge of 1 coulomb of charge أو كات يعني هركاتك باسي جماري إلكترون كان يكتبها this is the equation that you're supposed to use we'll say the charge on an object it is divided by the charge of the fundamental charge which is that we can say 1.6 and the charge of an electron which is 1.6 times 10 to the power negative 19 وطبعا أول جملة أنا قلت مان for electron and proton is exactly the same value ماشي أو charge electron بروتونيا electron negative proton positive أقدر قلت مان إيش magnitude positive و negative كنا نسيبها and these are the masses of electrons and protons and even neutrons you don't have to memorize the masses بس وان دبي memorize كي قلت مان charge neutron it is neutral or has no charges at all. Transfer of electric charge. Now, we can transfer the charge from one object to another by different methods. So we will be talking about this one soon. So charge objects here, when we rub one object against another, the electrons transfer from one of them to another one. أو كاتيكا إلكترون لا object دروات object HDK we can call that the transfer of charge دتواني بلين بو نوعي object كان charged ابن باشا so now they can attract one another باشا but if it is insulator these charges cannot move from one place to another there's another reason why we call them electrostatic تسيدي كشمانة conductor insulator ما هي فرق يوشتان سيبابا conductor it is a material that can transfer electrical charges easily باشا استاقر بتيه مثلا globe of course you have to connect that with a wire because you know that inside a wire there's a metal that is a conductor. So why conductors allow and transfer electrical charges easily? Because they have a lot of free electrons. The conductors are those materials that allow and transfer electrical charges easily because they have a lot of free electrons. But insulators, on the other hand, we call them insulator because they do not conduct electrical charges easily. Why? Because they don't have free electrons, or not enough free electrons, you could say. So what are conductors, Baba? Conductors, of course, you can say most metals or metals in general, all conductors here. For example, like copper, aluminum, silver, these are allow electric charges to move freely across their surface, right? Insulator materials such as glass, rubber, silk, paper, air, cloth, these are insulators. We have some other materials like semiconductors, Basha, or semiconductors. What are semiconductors? These are normally, we can say, materials. Basha, these materials have electrical properties between conductors and insulators. Normally, we can say in their pure state, they are insulators. But we can always add some impurities. We can mix some other material with them, some other elements, so that they can transfer electrical charges like semiconductors, like what, Baba? Like silicon, germanium, these are used in electronic devices. We have another type of material called superconductors. What are superconductors? Baba, superconductors are, we can say, certain materials below certain temperature, right? they become superconductor. Otherwise, normally they're not superconductor. Once we cool them down below certain temperature, they become superconductors. What does it mean, superconductor? Yani, they can transfer electrical energy, all of it, without wasting any, because they don't heat up, because they don't have any resistors or resistance, Basha, and they don't resist the flow of current here. Now, what else do we have? There are ways, Basha, of electrical charges that can be transferred. What are these ways? The first one we can say friction. What exactly friction do, Baba? Let's say you have a piece of cloth and then there is a plastic or plastic rod, Basha. Once you rub the two, of course, now electrical charges from one, of course, let's say from the plastic or from the cloth will be transferred to the plastic. Now the plastic, which is insulator, but because charges is transferred to the plastic acadebita negative, cloth acadebita positive. Now these two can attract one another. That is the first method, Basha. Another method that we have, it is a conduction. What is conduction, Baba? Conduction requires direct contact. For example, the Baba no qalama, it is negatively charged, and we have a sphere. Let's say let's say we have a sphere, Basha. Because this one has a lot of charges here, so once this pen, for example, touches this sphere, now some of the charges, will go to this sphere, Basha. This is called conduction. Conduction requires a physical touch. So if these two does not touch, charges cannot flow or move from one object to another, Basha. So obviously this happened. We can say direct contact between a charged object and a neutral object. Neutral be, then now it is possible for some charges here to move or to flow to the other one. This is how, Bablan, you can charge the other and the second object. So this process is called conduction. It is called induction. Induction here, a charged object, because this is sort of interesting to know. A charged object brought near a conductor, Basha. So like this plastic rod, it is electrically charged, Basha. So as you can see that there are a lot of negative charges here. Once we bring this plastic rod to this conductor, this is a conductor, by the way, conductor or sphere, that is a conductor, and you can insulate that too here. You can put it in an object so that charge cannot flow. Once you bring this one, clearly now negative and negative repel one another. When you got the negative now all of them have, or you can say transferred to the other side because negative repel. Basha, if the negative repelled, you can say the protons will come closer here because positive and negative attract. Even though proton can baba base knock nazul in the blend, but electron can only protons will be left, so it is the same as if saying protons came forward here. Basha. Now these two attract one another. So the next thing that we're going to connect or use a wire, Basha, because these are all electrons, so once you move a wire, connect a wire, now they're going to move to the earth. We call this process earthing. So there's less electron left or no electron left. And then after, as you can see here, that is this process, after the electrons are grounded in earth, so there's less electron left. After that, you can remove this plastic rod. And so now these protons that were here, for example, or there, now they're going to distribute, Basha, around Jan Bablin on the surface of the sphere, Basha, because they try to repel one another. So now you can see that this mostly is proton or positive. When we can say we've charged this metal sphere without any physical contact. Induction. Induction man plastic glass conductor Bablin sphere nzik de kena sphere conductor malera negative can they repel one another, positive and negative they attract, the one blend positive can then pressure. This is what happens here. Mandua area will connect this part with the earth, with the ground. And electron can baba the wrong area, but they go to the earth, now after you remove this one, Gutmano, protonana, they will distribute on the sphere. That's the reason why, Baba. So we can remember this. In induction, it can only happen if we use a conductor. This does not happen. Because if the sphere was not a conductor, these positive charges would have still remained here. Because if not, positive charge, if it is insulator, they cannot go from one place to another, or we can say they cannot distribute on the surface of this sphere. Basha kata دبي لندكشني أو سفيرة هيتمان conductor بي so that the charges can move. أگر نه charge can move نابن a process will not take place. We have the last method that we have, it is called polarization. And the polarization بابا good man is that if I have a ruler, rub it with a piece of cloth, it can attract small piece of paper. But what exactly, or why does it exactly happen, or that happen here? Now let's say this is a plastic rod, it becomes negative, Basha, and we have a small piece of paper. This small piece of paper, it is obviously neutral one, yeah. So we have positive, negative, let's say positive, negative. But we know that if this is negative, no, these negative will repel one another, one, yeah. And positive will be attracted. But because this paper is an insulator, so these charges cannot move that much. The only thing that they can do, just they can swap, for example. So this proton will come here, for example, and then this will be here. It's almost like, kind of like relocating themselves. It cannot travel from one part of a paper to another. And it can only change at its place very little. So this is called polarization. It's almost like make it polarized. How could man, if you, the same thing happen once you have a balloon, for example, that can stick to a wall. Okay, so if you have a balloon, you can see that it can stick to the wall. When yeah, so this wall clearly it is positive, negative, positive, negative. We can say when yeah. All right, so what exactly happens here? But because this wall is neutral, Baba, and it's also an insulator. أو charge أنا ناتوانا لناو insulator كيف كيف خان بران. But we know that positive, negative repel كاتا أو negative أنا, they will only swap themselves a little. They can only, for example, move a little, just almost like shift or swap, so that now positives are closer now. Basha. So now there is an attraction between positive, negative. This process is called polarization. Kata. What is polarization, Baba? It happens in insulating material, like I leave with man. Induction happens only if the sphere is conductor, but later it happens in insulating materials. The charge distribution shifts slightly when you charge can تنها يقيت shift بن يقيت سببنا rather than, but they cannot travel much because this wall is an insulator. Now these proton negative or positive negative charges can attract one another, and this balloon can stick to the wall just like this, or these as well. So in that case, of course, we can say when a charge object is brought close, creating a localized charge, Basha, that would be the fourth method of polarization. Let's recall them. Four method here for charges to transfer. The first by friction, the second by conduction. The third was induction, and then the last one is polarization. I got notes. These are important. Good man. Now section review. When a rubber rod is rubbed with a wool, the rod becomes negatively charged. Or if the rod becomes negatively charged, what can you conclude about the magnitude of the wool's charge? Negative, the wool must be positive. What can you say about the magnitude of the wool? So we'll say, the charges are quantized. If one object, let's say if this object loses one charge, if this one gains one electron, it loses one electron. If this is negative one because it gains, and the positive one because it lost it, they will have the same magnitude, but opposite, you can say charges, Basha. Will say the wool's charge has the same magnitude as the rod, but it's going to be positive. This is because of the law of conservation of, we can say, charges. What did the Millikan oil drop experiment reveal about the nature of the electrical charge? Of course, it revealed that electrical charge is quantized. Every charge has a specific magnitude, which is 1.6 times 10 to the power negative 19 coulomb. An object carries a negative charge of about 10 coulomb of charge. So this would be the charge on an object, Basha. Q on object. How many excess electrons? How many excess electrons? يعني تنجماري إلكتروني تدا يعني زيادة تدا أو كاتي. We'll use this equation. The number of electrons. Let's do or redo this one perhaps. Basha. بتمان هر كاتك لبيد ببابا لخد بنود بينوسا هكاتك بشارك قلتي how many excess electron or the number of electron, then you can always write this equation. N stands for number of electron باشا. N stands for number of electrons. That's it. The charge on the object, let's just write Q on object باشا. The charge on an object divided by the charge of an electronic. So that charge electronic and let's say an object carries a negative charge of this much, got that one negative 10 coulomb of charge divided by charge electron and the bisani 1.6 times 10 to the power negative 19 okati. In that case, we can get the number of electron, which is going to be, right, it is going to be 6.25 times 25 times 10 to the power positive 19 electrons. Let me not forget the charge of an electron is negative or negative يقدي cancel لكن طبعا negative كان جنا نسي. It's totally fine because جمارة ليرة بابا when we talk about how many electrons we'll talk about numbers يعني when you say negative or positive at this point because we دمانة ليرة جمارة electron كان باشا. So that'll be it. And then these two questions, I believe it's easy enough. There's nothing much about them. These critical thing, it says metals such as copper and silver can become charged by induction. Basha, while plastic material cannot be. One material, Basha, like a rod is brought into close to a sphere. Or the negative, they will move to the other side or other end of the sphere here. Positive will be left to this side. If this one is an insulator, can the charge go from this side all the way to the other side? No. This is why it doesn't happen if it is an insulator. It has to be a conductor. Critical thinking, the last one says, why is electrostatic spray gun is more efficient than an ordinary spray gun? But these electrostatic, if this is the spray gun here, or whatever. Okay, and here's the body of a car. Now the reason why, because now let's say this bubbling painting or whatever, it is going to charge the paint here. Yeah, bubbling the gun would charge the paint with one charge, let's say positive, while the body of a car will be charged with the other one and bubbling negative. This positive negative they attract one another. And what is the benefit of this? Baba, but zamdani away, Gutman, all the paint, bubbling hamu paint will be attracted to the body of a car. And that also ensures bubbling even coating. Hamu bubbling, all the body of a car will be painted equally and nicely without, for example, any fault, bubbling without any flaws. But also, Gutman paint it like it doesn't get wasted much. So these are the benefit of that. It uses charged particles to attract paint to the target surface, reducing waste and ensuring even coating. That'll be the end for this lesson. Inshallah, next lesson we'll talk about electrical forces. Till then, keep practicing and I'll see you soon, inshallah. Assalamu alaikum wa rahmatullah.